Eight minus a negative 1, which you just went ahead and changed to plus, minus a negative 1 squared. Okay, what did this become when you subtracted it? Oh, okay. Well, then let me do that middle step for you. That should be negative 6 squared. That should be 9 squared. So when you put it all together, was that 36 and 81? Yeah. 36, 81, was that 127? 125? 117. I was way off. So is that what you got? Well, did you give it as a decimal? Did you just leave it as 117 radical? That's fine. Okay. If you found it as a decimal, it would be 10.8. If you missed it, my guess is that you tried to punch negative 6 squared into the calculator and it gave you negative 36. Raise your hand if that happened to you. It's okay. It's nothing to be ashamed of. It happens. Who punched negative 6 into the calculator and got negative 36? Nobody? Okay, then. Never mind. Why would it have told you negative 36? Anybody remember? It's not wrong. It does the order of operations. If you would put it in without parentheses, it's going to do exponents first, 6 squared, and then stick on the negative. So if you're going to use a calculator, don't forget to put it in parentheses. So, distance formula. Questions. All right. Today, we are doing 7.1, the Pythagorean theorem. I'm going to go as far as to say this is the most important theorem you're ever going to have in your entire life. In math. What?
What's the most important theorem outside of math?
I don't even know if the rest of life has theorems. But I'm guessing it's like the breathing theorem. Never inhale and until you can say. Nope.
There you go. Going to that. In order to live and operate.
Pythagorean theorem. Now let me. Did you just use the pause feature?
That's mine.
Well, you don't have the pause feature just for you.
Yeah.
You're just like the captain of the pause feature. Let me show you in a nutshell why the Pythagorean theorem is helpful to us. It is an easier way to find the distance between 2 points or the third side of it. Yes. Excuse me?
Oh my God. Lost ticket.
I don't know. Maybe there were some racists in here a long time ago. Anyway, what were the coordinates from your DOM? Who can tell me what the coordinates were from your DOM?
-4, 8, 2,
Excellent. That's what I needed. Thank you. -4, 8. Now this is just a sketch. -4, 8. What was the other one? 2, -1? 2, -1. Right there. Alright. Now, if I were to make that into a triangle, let's say I wanted to find the distance between them, but I didn't want to use the distance formula. If I made that into a triangle, these would be the legs. That one right there, well, it's not straight because I'm not a very good artist, but you get the picture. Now, how could I, oh, wow, it's really bad. How could I find the lengths of those two sides of the triangle? The easiest way.
You just count.
Yeah, count. It's 8, so 1, 2, 3, 4, 5, 6, 7, 8. But then it went down. It was only supposed to get under this one, but I'm really loud to do it. 9. So that side was 9. Good. Because we went down. When you're finding a length, it's always positive, but that's a good thought. And then for the x, 1, 2, 3, 4, 5, 6. I'll keep it like that. 6. All right. Now you were asked to find the distance between those 2 points, which is the only side missing on our triangle, right? This is a right triangle. Here is the Pythagorean theorem in a nutshell. It's a squared plus b squared. That's right. Okay, well, I'm glad to hear you've heard it. This will be an easy lesson. So, that'd be 9 squared plus 6 squared equals c squared, which is the hypotenuse, That's 81 plus 36 equals c squared. Very good. And you should notice you get the exact same thing as you did when you used distance formula. The distance formula and the Pythagorean theorem are like first cousins. No, I'll even go as far as to say they're brothers. They're brothers. They are derived from the same exact principle. The only reason we need them differently is because the distance formula is best used with coordinates in case you don't feel like drawing it and counting it. And the Pythagorean theorem is more used when they just give you a triangle. Today, I'm just going to be giving you triangles, not even with coordinates, and say, hey, what's the missing side? And you're going to use this formula all day. Here's that official formula written in, well, actually. Does anybody need me to leave this up there for a moment? Most important thing about using the Pythagorean theorem is you have to have a right triangle. If it is not a right triangle, you cannot use it. And when you're dealing with a right triangle, you're dealing with two legs and a hypotenuse. Now, who can tell me the easiest way to always pick out the hypotenuse? That's the way I like to remember it. Malik, you raise your hand. You're unraising it? Okay. Well, opposite from the right angle is the way I always remember it too. Wherever the right angle is, it's the side directly opposite of that. The only side that the right angle is not touching is the hypotenuse. That's important because in the formula, you don't have to record that down as a theorem. You just need to know that the Pythagorean theorem is the formula. That's really all you need. The hypotenuse. This is one of the more important things of the day, if not the most important. The hypotenuse is the side that goes by itself. Always. It won't always give you the two legs and ask for the hypotenuse. And it's going to be tempting for, let's say they gave us A and C, and they asked for B. It's going to be tempting to be like, oh, number, solve for this. No. Whichever one is the hypotenuse is the one over here by itself every time. Even if they give that to you, that's the number over there by itself. So quick example. What if they had given us, just making up an example here, 5 and 3. To solve for the missing side, A, you would have A squared plus 3 squared equals 5 squared. You do not just make the one you're looking for the one over there by itself. Always the hypotenuse. And then you could subtract and all that stuff. And we'll do examples like this. But I just wanted you to see the setup. We'll do lots of examples. Questions. We're going to be doing several examples right now, and the first thing I'm going to ask every time is, are we looking for a leg, or are we looking for a hypotenuse? Every one of them will be a right triangle. I didn't throw in any curveballs like that today. Okay. Here's one. Oh, dang it. We gave it to you in the directions. Well, regardless, which piece are we looking for, Precious? Yes, but is it a leg or hypotenuse? Hypotenuse, which means, exactly, you're looking for the C. So you would set it up. A squared plus B squared equals C squared. Or, in this case, X, since they've already labeled that. A squared plus B squared equals C squared. The math's going to be really redundant today. But at least 10% of the math ACP can have something to do with the Pythagorean theorem. Like, not even a joke. There is a right triangle in so much math it's not even fun. Most important theorem that you're going to need outside of this class. You're going to need in every other math class you take. What's 9 squared? What's 12 squared? What is the two of those added together? 225. Now, let me, in case you haven't used, of course all of you should have used it by now, but in the off chance that you haven't, let me show you how to take the square root on a calculator. So we need the square root of 225. Second x squared is the square root symbol. Second x squared is the square root, and then we're taking that of 225. That's how you solve for a negative being squared. You take the square root of both sides. And what is it? 15. 15. Very good. Very, very good. Questions? Well, all right, let's try another one. All right. Actually, we'll come back to that part of the problem. Oh, let's see. Elijah, are we looking for, that's a tricky question, the leg or the hypotenuse? Where's the right angle? Here's the right angle, right? Now, what is directly opposite? Is that the number we're looking for, or is that given to us? That's the hypotenuse, so we're looking for a leg. Very good. So, not that we didn't already do this one. Malik, how am I going to set up this equation? Yes, sir. You can go. Well, you're giving me the formula. That's fine. But what can I plug into it? Okay. All right. There you go. Okay. Third time's the charm. All right. Punch that in. That's 9 equals 25. What do we have to do now? Hold on. Okay, never mind. Don't hold on. Subtract the 9. Need to get the x by itself. Subtract the 9. Starla, how do I finish this up? Square root. And what do you get? Blake, what do I get? 4. That, we're not doing that today. But I would be asking one if I needed to know. Yes. I doubt it. Yes, it is.
On page 433,
yes.
At the very top, it has a picture of a dude playing with the pillow. It's like they got little pictures of like little animals. It's got some dude sitting there jamming down on his guitar.
Anyway, to answer your question, I don't know. Yes.
So the hypotenuse always on the bottom.
Well, it's not always going to be on the bottom. It's always going to be the one directly opposite your right angle. Okay? All right. Now, this particular problem yielded us a Pythagorean triple. A Pythagorean triple is when all three sides are whole numbers. So, like, a question on a test would be, here's a triangle. Does it form a Pythagorean triple? Is it a right angle with all three sides being whole numbers? Is it? Yes, it is. So this one is a Pythagorean triple. That's the only other piece of vocab of the day. Right triangle, why does it matter? Just a piece of vocab. Well, no, Pythagorean triples are handy. See, you're going to get to the point where, like 3, 4, 5, that's the most obvious one. That'll save you a lot of time on the test, the quiz, the ACT. If you see right triangle with a 3 and a 4, or 4 and 5, or 5 and 3, you're like, oh, I recognize that. 3, 4, 5. It's just, they're the ones you're going to notice again and again and again, and it'll save you time. You won't even have to do this for this problem, probably by the end of the day. The most common Pythagorean triples are 3, 4, 5, 6, 8, 10, 5, 12, 13. Those are the most common ones. Questions? Yeah, that forms a Pythagorean triple. All right. Do you have a question? Just that they're all whole numbers. That's it. If all three fit into the Pythagorean theorem and are all whole numbers, Pythagorean triple. Most of them will be decimals, and they won't be Pythagorean triples. Okay. Elon, what are we looking for? A leg or a hypotenuse? Guess again. There you go. Oriana, how do we know this is a hypotenuse? opposite of the right angle. Very good. And Drew, how am I going to set up this equation? Very good. So I'll let you guys work that out. Let me know what you get for C. If it's not going to be a whole number, just give me a decimal for today, for one decimal place. And the reason is, if you give me a radical, then I have to substitute radicals, and that's not really the goal today. So just give me a decimal to one decimal place, and that will suffice. I'm hearing a 7.2. Can I get a second? Yes. Okay. Any questions? Does somebody want to see another example of one of these? No? Good, because I don't have any more. The next thing, oh, that's not true. Just kidding then. Okay. What if it asks for this? What if it asks for the area of a triangle? Then that's pretty easy. Area. Area. Who can tell me what the area of a triangle is? I've been Mariana from one right. Sure, do you know? Nope. 1/2 base times height. 1/2 base times height. And we learned that the base forms what with the height? Anybody remember? A right angle. So what's the base here? Well, the base of the whole triangle would be 10. What's the height? It's h. Do we know it? Can we find it? 10, 10. It goes with what we were doing today. Yes! Love it. Donovan, how are we going to solve for it? That's right. We can solve for h using the Pythagorean theorem. Then we're going to take that h and plug it into our 1/2 base times height formula. This is for the area, 1/2 base times height. We have to find h first, and then we're going to plug it into the whole thing. That's right. How did you know that off the top of your head? Because it's a Pythagorean triple. You're going to get to where you notice these things quick. It's okay if you didn't. We haven't even done one like this yet. So work it out. See what you get for h. Hopefully you get 12. And there you go. Pythagorean triple. He recognized. Leg of 5. Now, why aren't we using the 10? Why aren't we using the whole 10 for the Pythagorean theorem? One of these. Why aren't we using the full 10? Sage? It's not a right triangle. Very good. We have to look at a right triangle in order to use the Pythagorean theorem. So it's a squared plus a squared equals 13. And you should have gotten h equals 12 after you solved it. Anybody get something other than that they'd like us to take a look at? Everyone who did it got 12? All right, so Jensen, what is the base of this triangle for my formula? It forms the right angle with the height. Cameron, you want to help him out? That's the height. 1/2, that's the h. What's the b? What's the base? Stacy? It would be 10. 1/2 base times height. It's just the two sides that form the right angle. Will be your base and your height. So punch that in the calculator and somebody tell me what you get for the area. I think you multiplied 1/2 one too many times. 60. 60 what? Meters squared because it's area. Oh, because I was giving them, somebody told me them out of order, I just wrote them down like that. It doesn't matter. Multiplication is a commutative process. Oh, you did the area for one of the triangles? So you used a 5 right here instead of a 10? Okay. Yeah, remember, when you're doing it for the whole thing, you want to use the whole base. All right. Question. You cold?
No, that's why you go to check. That's a question.
Yeah.
Very mental load on the brain.
What?
Do you not get that reference to the brick?
Who's Barry Manilow?
I don't know, but it's on the brick.
Because that was made in like the 70s and I must be that old?
No, apparently so.
Well, your grade just dropped a whole letter. All right. I'm just kidding. So is this an ugly shirt or something? Is that what you're telling me?
That's what he goes. He goes, "You guys have any questions?" And then the troublemaker he goes, "Yeah, I have a question." Very mental load, no break the wardrobe, and he goes, "You'll get the answer to that question next time."
Obviously. Well, you know, I should have caught that reference. That is a classic. All right, find the area. Find the area. Okay, Elijah, how did you set up to find the H? Nope. Equals. Why is it equals? Because the 20 is the what? Big H word rhymes with hippopotamus. Now you tell me the word. Hypotenuse. The 20 is opposite the right angle. It is the hypotenuse. Because remember, when you find the H, you have to only look at one of the right triangles. Okay? So, if that's the hypotenuse, Cameron, go. Set up my formula for finding the H. At the end. No. No, it's really obvious, those of you who are active in the lesson, those of you who aren't, because you can't answer my questions. Hold on. Let me re-erase this again. Rachel, walk me through. You'd get 16 on both sides. Very good. 16 squared. Very good. Very good. Because now you have two sides of a right triangle, 16 and H, and you have the hypotenuse. And when you work that, what did you get? That was a Pythagorean triple. That worked out. So if H was 12, try this again. Drew, if H is 12, how do we find the area? Most people. Which is? What is B? Very good. 32. And what's the height? Very good. Punch all that in. Yes, sir. I don't know if that is that right? 192 what? Feet squared. Very good. Pythagorean theorem, and then the area for a triangle formula: 1/2 base times height. If you can't answer the question, I'm going to start asking you every day, every question, until you give me some correct answers. That's the new rule. What? Fine. Yes. Homework. Yeah. All right.